Hi everyone, and welcome to 7.4, which deals with factoring special products. Okay, so we've been talking about factoring a lot. So this is chapter 7. Remember that factoring is taking a polynomial and then breaking it up into, binomials or monomials, breaking up into a product, right, of monomials and binomials that themselves cannot be factored in least terms. Okay, so let's say, for instance, here we need to remember the following. Remember that if you have a binomial that is squared, it has this pattern here: a squared plus 2a plus b. So in other words, I think we went over this before, but if you have a plus b times a plus b, you get a squared, ab, b squared, and then your final answer will be a squared plus 2ab plus b squared. So the same thing here. You can go ahead and do the box on your own to check it, but it is true, I promise. So the difference between the two is that if you have a binomial that's separated with a plus, the whole thing, the pluses here are the same. And if your binomial here is a minus, there's a minus sign in there, then your middle term will be negative for your answer. So we went over this before, but could we go backwards? So what does that mean? So if we knew and could recognize that something was in this pattern where you have the first term squared, the last term is a perfect square, and the middle term is a product of the two terms times 2, twice the product of the 2, then we could factor it theoretically, right? We could go backwards. It would make sense, right? So it's like thinking to yourself, well, if 3 squared is 9, then I can say that 9 is equal to 3 squared. That's the same thing here. That's what we're saying. So the idea of this section is to be able to look at trinomials and identify perfect square trinomials, okay? They're called that because they factor into a binomial that is squared, okay? All right, so let's go ahead and do that. So remember the pattern. The pattern is if you have a trinomial that's of this form, okay? Remember that a and b could represent anything, right? You can express it as you don't have to go through AC method or the other methods to factor. You could just go ahead and put it into this form. So let's look at this. Okay, so is the first term a perfect square? It actually is, right? It's 3x squared. Is the last term a perfect squared? Yes, it is. Okay, so the questions that you need to be asking yourself, okay, when you look at a trinomial to use this shortcut, right? So first question is, is the first term a perfect square? Perfect square, and then 2 is the last term or the third term, right? A perfect square. This is with, of course, with the understanding that, it's in the right format, right? Ax squared plus b squared, plus bx plus c. And then 3 is the middle term equivalent to twice the product of a times b. So, 2ab. So what does that mean, 2ab? So if a is what's being squared. So this here, the 3x, in this case, you don't have to write this out every time, but I'm just telling you here. So in this case, a is considered 3x, and then b would be 2, okay? So notice, okay, so we have that. Now the question is the middle term, what's 2ab then? So 2ab is going to be twice 3x times 2. So 2 times 6x, right? Which is 12x. So this is 2 times 3x times 2. So it does fit. So since it fits, we can say, okay, I can rewrite this as a plus b. So a, right, plus b and then square it. And that's it. You're done with factoring that problem. So as you can see, a lot of it is done kind of in your head, right? So it's nice because it minimizes writing. Okay, so first thing, is this a perfect square and is this a perfect square? How do you check if this is a perfect square? Well, take the square root of it, right? If it's a perfect square and you get something, without a radical, then it's a perfect square. If you take the square root and you get something that's not, there's no radical left, then it's a perfect square. So yeah, this is 2x squared. This 9 here is 3 squared. Okay, fine. Now, you need to start thinking, okay, here I have 2x times 3, that's 6x, times 2, twice that is 12. Okay, fine. So 2ab is going to be 2x times 3 times 2, so that's 12x. Okay, check. It checks, so then that's 12x is right. So that's, so then your final answer, okay, you just use this part only. So some people ask, well, what happens to the middle term? It goes away. It does go away because we're writing it in factored form, okay? So then your final answer is 2x plus 3 quantity squared, okay? So again, you asked, does the trinomial fit the pattern? Is the first term a perfect square? You write it that way. Is the last term a perfect square? You write it that way. Check the middle term. Is it 2ab? And then you write the square. So again, okay, so looking at this, square root of 81 is 9, and then 9. So this is a perfect square, so that's right. This one is 4 squared. The last term is 4 squared. Now the middle, so 2ab, you can even write this down, right? Just write 2 times 9y times 4. If you figure that out, what is that? Another thing is, if this is minus, this has to be minus 4 because minus 4 squared is 16, and then the product has to be negative, okay? So 2 times 9y times, this becomes negative 72y. Oh, wait, that's exactly this. Okay, fine. So then this is, this checks. So you don't even have to write it again. You could just go from here and just say, okay, this is going to be 9y minus 4 squared. And that's it. And then I guess if you want to check by multiplying, fine. You can go ahead and multiply it. 9y minus 4. 9y minus 4. 81y squared. Positive 16 minus 36y minus 36y. So together is going to be negative 72y. So then you get 81y squared minus 72y plus 16, which is exactly what we started out with. So if you want to check, you can just use box method or however, FOIL it out, or even the perfect square pattern, but that's just going to get back to where you started. Okay, so let's do a couple more. All right, let's see. This one has a y term. So the first one, what is that? That's 6x squared. The last one is going to be 7y squared, okay? And it's a positive, right? So the question is what is 2 times, I'll write this in pink, 2 times 6x times 7y, okay? What is this? And if this equals each other, if these two equal each other, then we're good. So 2 times 6, 12 times 7, that's going to be 84xy. This becomes 84xy. So it does check. So then fine. So then your last step is you just go 6x plus 7y and then squared. Okay. Let's do another one. Okay, so square root of this is going to be 8m, right? This is going to be 7n. So even now, you can start thinking in your head, okay, 2 times 8m times 7n. That's going to be what? That's going to be 16 times 7, which will give me 112 mn. So then that checks, right? That checks. So then you can go ahead and just write 8m plus 7n squared, okay? All right, let's do another one. Or did we just do this one? I don't know. Let's just do it anyways. Okay, this one has a minus, so you can you have to think, okay, there's going to be a minus. So this is going to be, but before we even do that, notice what is happening here. They have a common term of y, right? And also, what else divides into all three? I think 4 does. So let's factor out 4y. So remember, so this is good because this example is good because it reminds us that, hey, you make sure that you're checking the GCF. So then 4y, if I factor out 4y, I get 9x squared minus 12x plus 4. Okay, so that's good. So if I factor out the GCF, now it's looking kind of like a, perfect square trinomial, right? So this is going to be 4y. So what you can do, let's see, before we write out the answer, let's go ahead and see if this works, right? So this is going to be 3x squared. This one's going to be 2 squared. And then we need to ask ourselves, okay, somewhere 2 times 3x times 2 is going to be 12x, right? But then it's minus, so that's fine. So this should be a negative 2 here. Okay. So then it checks, right? Just the sign. You have to watch the signs. So if this is minus 2, then that will change this to be negative. So then this is finally 3x minus 2 squared. And then the 4y, don't forget your 4y. And that's fully factored. Okay. Okay, so let's look at this product of conjugates pattern. So let's say you have A and B real numbers. If we were to multiply a binomial and its conjugate, so remember that conjugate is just the same binomial except the sign changes, okay? So if you multiply that out, you get this A squared minus B squared, and it's called difference of squares. So the nice thing, this one is like the super... this is like everyone's favorite. Why? Because it's really easy to identify a difference of 2 squares. It's not even a trinomial, it's a binomial, and it factors out so nicely. Okay, so let's go ahead and ask, okay, so what are the steps? Does the binomial fit this pattern, a squared minus b squared? Is this a difference? Make sure that there's a minus. And are the first and the last terms perfect squares? So then if so, you just basically go a squared, a minus b, a plus b. So let's go ahead and do one. So factor x squared minus 4. So x, that's a perfect square. That's just x squared. 4 is a perfect square. That's not 4 squared. That's 2 squared, right? So you can take the square root if you want to find it, but that's just 2 squared. So since this is a difference of squares, we can write this as x plus 2, x minus 2, and be done with it. So that's so nice. Okay, okay, great. So is it a difference? Yes, these are the squares, and that's it. Okay, so 64y squared minus 1. 64y squared is a perfect square, right? Take the square root of it. It becomes 8y. Minus, and then 1 is just the square of itself, right? So now that I have it like that, I can write 8y plus 1, 8y minus 1. You'll get to be so good at these, you can just bypass this step and go straight to here, okay? All right, so let's do another one. 196m squared minus 25n squared. So let's see, is 196 a perfect square? And it is, it's 14. So 14 m squared minus 5n squared. So then that's going to be 14m plus 5n, 14m minus 5n. See how nice that is? That's so nice. Okay, so what about this? We have here 100 minus h squared. So then that would be 10 squared minus h squared. So 10 plus h, 10 minus h. Let's do a couple more because they're fun. Okay, x to the fourth, y to the fourth. Now, interestingly enough, okay, notice this pattern here. So this is x squared squared minus y squared squared. So it is a difference of squares, but just keep watching. This one's a little interesting. So this is your a and this is your b. So your product is going to be x squared plus y squared, and then x squared minus y squared. So usually you would say to yourself, oh, I'm done with this problem. You know, I have no, I'm done. I'm done, totally done with this. Then I have x squared plus y squared. But this here is actually a difference of squares again. So then you need to write that as x plus y, x minus y. See? So nice. Okay, so here, so then here, what it can be, this doesn't exactly look like it's in the squared pattern yet. So I notice there's a GCF here, and also these are both divisible by 2. So the GCF to me looks like it's going to be 2y, yeah? So let's factor that out first. Okay, so then that gives us 4x squared minus 9, yeah? So this is a difference of 2 squares, right? This is going to be 2x squared, and this is 3 squared. So then it factors out to, you have the 2y, of course, don't forget him, 2x plus 3, and then 2x minus 3. All right, now this last example, first of all, we notice that this is perfect squares, but can you tell me what's wrong? Is there something keeping us from using the formula? Yes, there is. If you said, hey, this is a sum, not a minus, you were right. So if you thought that, congratulations, you did a good job. So then this is not factorable, okay? So there are some, binomials and trinomials that are not factorable, okay? They're also known as prime polynomials, okay? But this case, if you have a sum of squares, then that's fine. It's not factorable, okay? All right, and this is the final thing that I want to talk about in this section, and it's the sum and differences of cubes. Okay, so we already did difference of squares. We know that sum of squares is prime, so we can't factor that. But you can factor a sum of cubes and a difference of cubes. And it's this pattern. Okay, so this one, the easiest way to go about this is just recognize A and B and then plug it into the formula. Okay, note the following. Okay, so if it's A plus B, your first sign is the same, then it alternates, right? Then it goes plus, minus, plus. The last sign is always positive. So for the minus case, the first term has the same sign, then it alternates, okay? But then, of course, the last term is positive, okay? So how to do that? We need to see if it fits, if it's the sum or difference of cubes, so if it's a cubed plus b cubed or a cubed minus b cubed. Then if it does, if the first and last terms are perfect cube and it's a sum or difference, we can just use the pattern, okay? And then simplify. So let's go ahead and talk about this. So a cubed plus b cubed is equal to, and then a plus b, and then you have a squared minus ab plus b squared. So what did I write? I wrote too fast. Sorry. So b squared. Okay, so fine. So this looks like a sum of cubes, right? This is x is a, and 64 can be written as how? Let's see. So we already have x cubed. But I don't know why I'm writing like weird symbols. Okay, so plus, my mind is going too fast. So this is 4 cubed. I'm like super excited for some reason today. Okay, so this is 4 cubed, yeah? So that means A is X and B is 4. So you can write it off to the side, or you can underline it and write like this, whatever helps you. But make sure you identify, this is really important, you identify your A and B correctly. It's not 64. B is not 64. That's B cubed, okay? B is the actual 4. That's 4, the cube root, right? So now all I'm going to do is I'm going to say, okay, fine. So then I have X cubed plus 4 cubed. So I'm going to just plug it directly underneath, okay? So that's going to be here. So A is X plus, and then B is 4. Then A squared is going to be X squared minus, and then you have X times 4, right? Plus, and then you have 4 squared. So now we basically just directly plugged everything in. And now we get to simplify this. So X plus 4, and write it a little bit neater, hopefully. X squared. X times 4, we don't really write that. We write 4X, okay? And then plus 16, because 4 squared is 16. And that's it. Okay, so the important step is to, really the most important step is to identify that they are a sum or difference of cubes, and then identify A and B correctly. Okay, once you do that, it's super easy to just plug it into the formula and simplify. That's like really no problem. Okay, so that we have here, 10,000. And x cubed minus 1,000. So x cubed is a cube, so that's fine. So you have x cubed, so A is x, right? And then here you have 10 cubed is 1,000. So B is actually 10. So now it's minus, and the minus, remember, it's A cubed minus B cubed. Of course, I mean, I don't expect you to memorize this like immediately, okay? But if you do enough problems, if you work enough problems, you will end up memorizing it. That's just how it is. It's helpful. It's super helpful to like memorize formulas. You don't have to keep putting up. Okay, this is a side note. If you have like a sticky note, like, those little sticky pads or something, Post-it notes, go ahead and write the formulas on there while you're doing your homework, while you're doing your Newton. You have it right there. You can look at it and you go, okay, yeah, that's what it is. I used to just write it every time I did a problem. I would write out the whole stinking formula because it really helped me commit to memory. So whatever works for you, Okay, fine. That's enough. So x cubed minus 10 cubed is, so then I'm just plugging it in. A is x, boom, bringing down the negative, minus. B is 10, boom, I'm just following the formula. We're like letter by letter. X squared plus, so A is X, so that's X times 10, right? And then plus, and then the last one is going to be 10 squared. Okay, fine. So then just, cleaning it up. So this is going to be X squared plus, and then of course the right way is 10X plus 100. Okay? All right, now let's do some random problems and see if you can identify which ones these are or not. So we have here 512 minus 125 to p cubed. So then we ask ourselves, what is 512 a perfect cube? Probably is, right? Well, you can take the cube root of it on your calculator. Or you can literally just put in your calculator, if you wanted to find this out, if this is a perfect cube on your calculator. So calculator moment, fine. You would put, you would hit parenthesis. Well, actually, you don't really need parenthesis, but that's fine. So 5112. Then you would hit the caret symbol. Then you would hit the parenthesis. You would put parenthesis, and then a 1, and then the division symbol, and then a 3, and then the end parenthesis, and then you would hit enter. So that would give you the cube root. So the cube root would be 8. Now, in this case, some calculators have this button. If you have this button, use it. That's what this is, okay? So anyway, so that's just calculator moment. here, 512. Let's go back to this. So I found out that this is 8 cubed minus. Now, this is 5 cubed. It's kind of common, but if you didn't know that, you can go ahead and use your calculator to do that. Instead of 125, you would put, 512, you would put 125. Okay, fine. So then the formula, we love this formula now. It's going to become our best friend. Is that sad? Formulas are our friends. Okay, b squared. Okay, so then we have 8 cubed minus 5p quantity cubed. Right? So then just writing down, 8 minus 5p. So then you have 8 squared plus 8 times 5p plus, and then 5p, the whole thing squared. Okay, so then that becomes, I'm going to write it over here a little bigger, 8 minus 5p, and I'm going to, simplify this stuff. So 64 plus, now 8 times 5p is going to be 40p plus, and then 25p squared. So then that's it for this problem. So then here we have 64 minus 27x cubed. So 64 is 4 cubed, 3x cubed. 27 is 3x. So then let's go ahead and put that in. We have a minus b, so that's going to factor into 4 minus 3x. Then a squared plus 4 times 3x plus, and then 3x squared. So then that's going to equal 4 minus 3x, and that's going to be 16 plus 12x plus 9x squared. And that's it for that one. And I think we might have one more. Okay, fine. This one has a GCF, right? What's my GCF here? 5. Okay, if I factor that out, m cubed plus 8n cubed. Okay, so by now we should be getting kind of like, okay, this is the sum of cubes. That's going to be, a squared minus ab plus b squared. So then what is a and what is b? So the 5 can stay out. But here, the m cubed you have, and then plus 8, cube root of 8 is 2. Cubed, and then that. So a is m, b is 2n. So then plugging it into the formula, you can leave the 5 out, but you do have to include it ultimately because it is part of the problem, right? It is part of the expression. Sorry, not a problem. So m cubed minus, I'm sorry. A plus b. Why did I put a minus sign? Sorry about that. This is a plus. So m plus 2n. Then a squared. So m squared minus m times 2n plus 2n squared. So then simplifying this is going to be 5. And then you bring m plus 2n there. Okay, m squared minus 2mn. Okay, we usually write number and then letters in alphabetical order, the variables, plus 4n squared, and that is it, okay? All right, so good luck with everything, and I will see you guys. Happy studying, and I'll see you in the next video.